Hello, my name is Juang, and today I'd like to introduce my research, a model of 25 years of carbon exchange and its factors in the Harvard forest. So why study the Harvard forest? First of all, the Harvard forest is a temperate forest, and temperate forests account for a large portion of the forest carbon sink in the world. So when we're thinking about climate change, we'd really like to think about how do forests change in terms of their carbon sink when climate change is happening. Second of all, why the Harvard forest in particular? Well, the Harvard forest is a forest in central Massachusetts and is home to the environmental measurement station Eddy Flux Tower. And this tower contains the longest running Eddy Flux Tower measurement dataset in the world, so that we can use this to look at how are forests affected in the long term on a decadal scale. So this data was used for the forest ecosystem model, which is based off a paper by Urbanski et al., but is updated to include 25 years of carbon exchange data, as well as a look at the data grouped by 5-year rolling periods of time, so that we can look at a longer-term view of what's happening in the Harvard forest. This is all to answer the question of, can we use a model to quantify the relationship among temperature, sunlight, and net ecosystem exchange in the Harvard forest? Well, our null hypothesis says that yes, we can quantify it using the forest ecosystem model. So, I would like to walk you through what the forest ecosystem model does. So first of all, we start off with net ecosystem exchange, which is net CO2 in the Harvard forest. This value is outputted by a relationship of A1, A2, A3, and A4 that are in relationship to temperature, seasonal mean temperature, photosynthetically active radiation, or PAR, and PRI, which is the PAR ratio index, or a measure of leaf expansion. And so this model is divided into 3 different variations depending on phenologically defined seasons of Urbanski et al. And then a least squares regression is performed in order to see how does the predicted net ecosystem exchange outputted by the model compare to observed net ecosystem exchange from the Harvard forest. And here we have the outputs, which are A1, A2, A3, and A4, the residuals, the R-squared value, and the variance of residuals. So the first question we want to ask then, is the sample data representative of the forest ecosystem? And the answer is yes. What I found through looking at the standard deviation of the root mean squared error is that we only encounter a few different seasons where data coverage is not enough to be considered a valid representation of the forest ecosystem. And that is only in spring and summer, where data coverage is less than 10%. We then move on to look at, do model predictions fit observed measurements? And this is interesting because we have such a large variation between spring and summer and winter seasons. In figure A right here, spring and summer have a great R-squared value, meaning that the model is a good fit. And that means that temperature and sunlight correctly do account for the net ecosystem exchange in the Harvard forest. Meanwhile, winter doesn't have a great R-squared value, meaning that maybe the fit is not so great because there's another factor that could be accounted for in order to characterize net ecosystem exchange. Moving on, we want to look at how does the model respond to seasonal anomalies. And what we found is that the model can see seasonal anomalies through the root mean squared error. So in this example, we saw that when 2011 is included in the model cannot properly predict it, and the root mean squared error shoots up. And this correlates with the observed net ecosystem exchange and the observed photosynthetically active radiation. And we can see that in 2011, compared to the other seasons, which is in blue, we do have strangely anomalous net ecosystem exchange for a certain photosynthetically active radiation. So the model can see that. Finally, I wanted to look at, can the model see ecosystem response to temperature? And it was interesting because the model can, especially by season. And what we saw here in this graph is that respiration differs between different seasons, and also respiration occurs more in the winter and the spring than in summer and early fall. So in conclusion, quantifying factors of temperature and sunlight in relation to net ecosystem exchange is possible, especially in the summer months. However, we don't see as great of a fit in the winter months, meaning that maybe there's something else that we need. And second of all, we can see anomalies. And finally, the model can characterize this respiration versus temperature relationship using the model's parameters. So in future studies, I'd like to explore more these factors in the winter that aren't accounted for beyond temperature and sunlight, like maybe snow cover. So thank you for listening.